Another situation is a situation when the samples are not paired, but they are independent. So this is not before and after, but these are different objects, like different people. For example, the previous case is when you want to understand how the salary of a random person changes after this person have finished the college, for example. So, and you choose random persons, random people, and you observe their salaries before and after. For example, 1 year before finishing the college and 1 year after. And here, in this case, you want, for example, compare salaries in two different cities. For example, in Moscow and St. Petersburg. So you are interested in difference of mean salaries, of mean salary in Moscow and mean salary in St. Petersburg. And so you choose random people, random people here in Moscow, and you ask them for their salaries, and you choose random people in St. Petersburg. So these samples are independent. In previous case, these were salaries of the same people before and after, and here these are salaries of completely different people, those who live in Moscow and those who live in St. Petersburg. So in this case, you are to find S squared according to the formula you can see now. So this is a kind of a linear combination of the sample variance for x's and for y's, for the first sample and for the second one. And the formula for the confidence interval is also given. You can see it. So it is a little bit more complicated, as here you have x bar minus y bar. So x bar and y bar are sample means for the first sample and for the second sample respectively. You have x calculated according to the formula provided above, and you have the quantile of the student distribution with m plus n minus 2 degrees of freedom. So that can also be found in the table of the quantiles. And now let's consider the situation when the samples are independent. So let's say that there are students of two different faculties, and they try to pass an exam, and they got some grades on a 10-point scale, so from 0 to 10. And so we have 7 students of the first faculty, and their grades are 9, 7, 8, 5, 9, 6, and 3. And we have 8 students of the other faculty, and their grades are 6, 4, 8, 7, 6, 9, 4, and 5. So you see that these are independent samples. These are not the grades of the same students before and after some, I don't know, additional classes or something like this, but these are grades of different students, randomly selected students of the one faculty and the other one. So they ask for the 95% confidence interval for difference in means. So 95% confidence interval for mu x minus mu y. That is what we need to find. So let's start. So we need sample means. We need x bar and y bar. So x bar is
1 over 7, 9 plus 7 plus 8 plus 5 plus 9 plus 6 plus 3 and this is equal to 6.71. And y bar is 1 over 8, 6 plus 4 plus 8 plus 7 plus 6 plus 9 plus 4 plus 5. And this is approximately 6.13. Not approximately. This is the accurate value. So then we are to find the sample variance for the united sample. So how this can be done? We can say that we have 15 observations, 7 plus 8. So we have 1 over 15, and here we have squared differences of observations from the respective sample means. So here I have 9 minus 6.71 squared plus, and I do this with the first sample up to 3 minus 6.71 squared. And for the second sample, I subtract the sample mean of the second sample. So 6 minus 6.13 squared, and so on, up to 5 minus 6.13 squared. So this is the sample mean. And if we do all necessary calculations, we will find that it is equal approximately to 4.02. And this means that this is s squared, so s is approximately 2. Square root of s squared. So then we are to find the quantile. So as we are asked to find 95% confidence interval, then we say that 1 minus alpha is 0.95, and that means that that 1 minus alpha over 2 is 0.975. So the alpha is 0.05, alpha over 2 is 0.025, 1 minus alpha over 2 is 0.975. And so we need the student quantile with a number of degrees of freedom is m plus n minus 2. M and n are 7 and 8 respectively, so m is the sample size of the first sample, n is the size of the second sample. They are 7 and 8. And so here I have 7 plus 8 minus 2. And the level of the quantile is 0.975. So this is quantile with 13 degrees of freedom. And if we look to the table of the quantiles of the students' distribution, we will find that this quantile is equal to 2.16. Okay, so now we are ready to construct the interval. So here we say that this difference of means is from x bar minus y bar, that is 6.71 minus 6.13, minus s, that is 2 times square root of 1 over m 1 over 7 plus 1 over n 1 over 8 times the quantile, that is 2.16, and the right endpoint is the same but with plus here. So 6.71 minus 6.13 plus 2 times square root of 1 over 7 plus 1 over 8 times 2.16. So probability of mu x minus mu y being in this interval is 0.95. So difference of means is 0.58, and this expression 2 times square root of 1 over 7 plus 1 over 8 times 2.16 is equal to 2.24. So minus 2.24. Or finally, we can say that the left endpoint is minus 1.66 and the right endpoint is 2.82. So this is the answer. We see that in previous case, the sample mean was very close to 0, and so the confidence interval was almost 0-centered. Here we see that sample mean is not so very equal to 0, so mean difference, so this 0.58. So we see that we can say that grades of the students of this faculty, of the first one, is a little bit higher than of those of the second faculty. But still we see that 0 is inside the confidence interval. So the interval is of high confidence. So this confidence level is 0.95, and still 0 is inside the interval. So that means that with that situation when actually the mean is 0 is quite probable. By the way, we see that sample sizes are very little, so we have small samples, and so we actually I should say that you may ask, why do we work with such small samples here? So you can say, you told us that in statistics sample sizes are big, so we work with big number of observations, and you are showing us some examples where we have 7, 8 and so on, so 9 observations. This is not what they usually do in statistics. And yes, you are right, but I do this just for educational purpose. So to make it possible for us, for me to solve these problems manually, to show you how does it work. So that is why I'm using such small samples. In real life, we don't construct confidence interval with such low number of observations.